Welcome to Mobile Coding Academy. Learn principles, build confidence. Let's dive in.
Welcome to this deep dive. Today our mission is to really give you a clear visual explanation of a classic Android interview question.
Yeah, and it's one that actually trips up a lot of developers, even if they've been using the framework for a bit.
Right, so we are looking at a fantastic technical breakdown from Mobile Coding Academy today. And the big question is, how does Jetpack Compose know exactly what to recompose when your observable state changes?
It's basically the core magic of Compose.
Exactly. So let's just set the scene for you to visualize this. Imagine a really simple login screen composable. We have a variable isLoading, and we set it to false using mutable state of and remember.
Okay, yeah, classic setup.
Right, and because it's false, a standard login text button shows up on the screen.
Makes sense.
But then, you tap that button, iLoading suddenly becomes true, and bam, a circular progress indicator, little loading spinner appears instead of the text.
Just like that, which is what users expect, right?
Right. But here is the mystery. In the old Android view system, you'd have to, manually find that text view, explicitly hide it, and then inject a spinner view into the exact right spot.
Oh yeah, writing all those manual set visibility calls, just a total headache.
Yeah, exactly. But Compose didn't require us to do any of that.
Yeah.
So, how did it know this specific part of the UI depended on that iLoading variable?
Well, this is where the mechanics of it are just fascinating. The whole flow really starts when Composition first executes that UI code.
Okay, so on the very first pass.
Right, the initial run. As it goes through the Composable, it hits that if iLoading statement, and that act, the literal act of reading that observable state, is the key.
Wait, just reading it?
Just reading it, because Compose actually tracks that read. The snapshot system is sort of watching in the background.
Oh, wow. Okay, let's unpack this for a second. So the state rate essentially creates a dependency right then and there. It's almost like, it's like Compose sets a tripwire on that exact line of code.
I love that analogy. Yes, a tripwire is exactly what it is.
Right, because it's just sitting there waiting.
Exactly. So then let's follow the chain reaction. When the user taps login and iLoading changes from false to true,
the tripwire goes off.
Bam, the tripwire goes off. Compose immediately identifies the affected recomposition scope and invalidates it.
Okay, wait, let me push back on that a second.
Right.
Because if reading state sets a tripwire and flipping it invalidates the scope, what does that actually mean when it triggers?
What do you mean?
Does invalidation mean the whole screen just gets redrawn immediately? Does my entire app UI detonate instantly? That sounds like a performance nightmare.
Okay, no. And honestly, this is a really crucial distinction, especially if you're in a technical interview.
Right, because people probably get this wrong all the time.
Oh, constantly. Beginners often think Compose just remembers where state was read and immediately redraws everything. But the precise engineering reality is that reads are tracked just to invalidate and then schedule those scopes.
Schedule. So it's not instant.
Not at all. Invalidation just means that specific dependent composition work is now considered out of date. It's like a flare going up saying, hey, I need an update.
Got it. So it doesn't run right that millisecond?
Right. The runtime coordinates it within its rendering pipeline. It waits for the right moment, then evaluates just that UI block again to reveal the spinner.
Okay, so if we had to boil this down into a golden formula for you to remember for an interview, it would be state read leads to dependency.
Yes.
Dependency leads to invalidation.
Right.
And invalidation leads to recomposition.
That is exactly it. State read, dependency, invalidation, recomposition.
Man, that really clears it up. So Compose doesn't just randomly rerun code. It really surgically targets those dependencies.
It's highly optimized, yeah. But, it does leave you with a pretty interesting question to explore on your own.
Oh, what's that?
Well, we know Compose invalidates the affected recomposition scope, right? But what exactly defines the boundaries of a recomposition scope in the runtime structure? When that boundary is drawn, just how much code actually gets skipped during a recomposition pass?
Oh, that is a great question. Something for you to mull over next time you're profiling your app's performance. Thanks for joining us on this deep dive.
We hope today's deep dive gave you one more engineering principle you can carry into your next challenge. Thanks for learning with Mobile Coding Academy. See you in the next deep dive.